hopefully that video helped you learn some tricks for memorizing the special trig functions for 30, 60, and the 45-degree angles. Now we're going to use some of those tricks to find the trig functions for different angles, whether they're in degrees or radians. So, for example, this first one says, find the 6 trig functions for the angle of 3 pi over 4. So, I hope you know that 3 pi over 4 is going to end us up in that quadrant. 3 pi over 4 being 3/4 of 180 degrees. It would be a 135-degree angle, but we need to use this reference angle because we only memorized that right hand, or the first quadrant with your left hand trick. So we are going to use the reference angle of pi over 4. And so you can still use your left hand and do the pi over 4, but now you just have to remember that some of these numbers are going to be negative. For example, because we are moving left, that this value is going to be negative. Since it's still in the positive y direction, that y value is going to be positive. And so if you use the left-hand trick to remember a 45-degree angle and you put down that middle finger, we end up with the square root of 2 over 2 and the square root of 2 over 2. This one, however, has to be negative. And we can write that one down as 1. So the 6 trig functions are going to be the sine of 3 pi over 4 is the opposite over the hypotenuse, because that's just 1. Sine of 3 pi over 4 is the square root of 2 over 2. Cosine of 3 pi over 4 has the same value, but it is negative. So it's negative square root of 2 over 2. And then tangent of 3 pi over 4, again, because the opposite side and the adjacent side have the same numerical values, it's going to be 1, but because we've got a positive number over a negative value, the tangent is going to be negative 1. It asked us to find all 6 functions, which means we need to find the cosecant of 3 pi over 4. And so for that, we just have to flip this function, or flip this fraction right down the reciprocal. So it would be 2 over the square root of 2. I don't like the square root in the denominator. So now I end up with 2 square roots of 2 over 2. And those 2's are going to be able to cancel. And so the cosecant of 3 pi over 4 is just the square root of 2. I know my secant value is going to be the same numerical value, but because it's the inverse of cosine, the reciprocal of cosine, it's going to be a negative value. So I know that that's going to be negative square root of 2. And then cotangent is the reciprocal of negative 1 over 1. It doesn't matter, that's still negative 1. The next example asks us to find the 6 trig functions for a negative angle, and it's measured in degrees. So I can draw out my negative 120-degree angle. I still start at my x-axis, but now I go in the opposite direction. So I've got negative 120. I want to use my reference angle, however, as my terminal side and my closest x-axis. And so I'm going to take this point and I'm going to draw my perpendicular. So I've got my right angle up there. And I have to use this reference angle. So that reference angle is going to be a 60-degree angle. Now I can label my 3 sides. I know my hypotenuse is always going to be 1. And so now, even though it's in the 3rd quadrant, you can still use your left-hand rule. So put down that ring finger to figure out the x and y values. You've got negative 1/2 and negative square root of 3 over 2. I know they're both negative because I had to move to the left and I had to move down. Oops, I'm sorry. Those are reverse. It does help too sometimes if you realize that your drawing is a little bit off, to make sure that that angle looks like it's 30 degrees. And then it's easier to see which one is 1/2 and which one is the square root of 3 over 2. Accurate drawings are always helpful, but we still have our right angle right there. So use that left hand trick. And so now, again, to find the sine, cosine, tangent values, we will use the sine of our reference angle. The sine of negative 120 degrees is going to be the opposite side. So that should be negative square root of 3 over 2. The cosine of negative 120 degrees is the adjacent side. So it's negative 1/2. And the tangent of negative 120 is the opposite over the adjacent. So opposite over the adjacent, instead of dividing by negative 1/2, I'm going to multiply by the reciprocal. So I'm going to multiply by negative 2 over 1. I see that my 2 is going to cancel, negatives are going to cancel, and my final answer is just the square root of 3. Why don't you try to find the cosecant, secant, and cotangent videos, or values, and then pause the video, and I'm going to write down the functions right now. So if you want to try it on your own, now's your chance to pause it. But the cosecant of negative 120 is negative 2 square roots of 3 over 3, I'm sorry. The secant of negative 120 is negative 2. And the cotangent of negative 120 is the square root of 3 over 3. So hopefully you got those right. And actually the last 3 problems should go a little bit quicker because it's only asking for one value. So just get some extra practice at your reference angles and trying your left hand trick out. So 5 pi over 6. Start with my initial side. 5 pi over 6 is less than pi, so it's less than 180. We end up with 5 pi over 6 right there. We are missing 1/6 pi, or 30 degrees. So if you want to write in pi over 6, that's going to be our reference angle. Again, the reference angle is always formed by the terminal side and the x-axis that it's closest to, and we draw our perpendicular line to the x-axis. So using that left-hand trick, we can label we can always label the hypotenuse as 1. But pi over 6 is our 30-degree angle, which means that the y value is going to be 1/2, and the x value is going to be the square root of 3 over 2. Now I just want to check my signs. The 1/2 is a positive value, but because square root of 3 over 2 is going left, that one's going to be negative. Now that we've got that labeled, the question asks, what is the cosine of that? And so the cosine is going to be the x value, the adjacent side, over the hypotenuse. And so this is our cosine value. So we can say that the cosine of 5 pi over 6 does equal negative square root of 3 over 2. I want you to do 2 things right now. I want you to check a decimal answer for negative square root of 3 over 2. And then type in the cosine of 5 pi over 6 and make sure that those 2 decimals really do equal the same thing. So the square root of 3 over 2, negative square root of 3 over 2, that should give you negative 0.866. And making sure that your mode is set to radians, type in cosine of 5 pi over 6. Should give you the exact same answer of negative 0.866. That's a way that you can check your answers while you're working on your homework to make sure you've got the right thing down. Okay. Again, at any point, if you want to stop, try the next two on your own, and then fast forward to see if you've got the right answers to make sure you've got it down. You can do that. Taking a look at the next one, we've got negative 11 pi over 4. 11 over 4 is more than 2, so I know I have more than one full revolution, and actually it's going in the negative direction. So one full revolution in the negative would be negative 8 pi over 4. So I still have to go another 3 pi over 4, which will take me right there. This reference angle formed by my terminal side and the x-axis is going to be a 45-degree angle, or pi over 4. And I've got my right angle here, which gives me my hypotenuse, or my radius of 1. Because it's a pi over 4, if you're using the left-hand rule trick, you can put down your middle finger, and you end up with the square root of 2 over 2 here, and the square root of 2 over 2 there. I want to check my signs, and because I'm going to the left, this x value is negative, and because I'm going down, that y value is negative as well. Now it says, what is the tangent of that angle? So tangent is going to be the opposite side over the adjacent, but because the opposite and the adjacent have the exact same value, when I divide one by the other, I'm going to get 1. And I might want to double check, should it be positive 1 or negative 1? It is a positive value because I'm dividing a negative by a negative, so I get my positive answer. And the last one is the cosecant of 29 pi over 3. So that is well over 2 pi, or well over 1 revolution. We've got 6 pi over 3. Another revolution would be 12 pi over 3. 18 pi over 3. 24 pi over 3. And now I'm getting closer. I've only got 5 pi over 3 left. So 5 pi over 3 is almost another full 6 pi over 3, or a full revolution. I am missing pi over 3. So that is my terminal side. And it might be simpler if you found out that the coterminal side was just 5 pi over 3. So you could say 29 pi over 3 is coterminal with 5 pi over 3. And then you can just graph that one. Okay. So there's my terminal side. My reference angle is going to be formed by the terminal side and the x-axis, which is pi over 3. And so what it's really asking me to do is find the cosecant of pi over 3. So I want to label my sides. I've got my right angle formed with my x-axis. I've got 1 as my hypotenuse, using the left-hand trick for, I believe that's a 60-degree angle, pi over 3. So I end up with 1/2 here, and the square root of 3 over 2 over here. So we've got to remind ourselves, what is the cosecant? Cosecant is the hypotenuse over the opposite. So that would be 1 over the square root of 3 over 2. Or it's the reciprocal of square root of 3 over 2. So we could write it as 2 over the square root of 3. And I hope by now that you realize that that is not an acceptable final answer, because there's the square root in the denominator, the radical in the denominator. So we need to get rid of that by multiplying by the square root of 3 over the square root of 3. And we get 2 square roots of 3 over 3. And now I just want to double check that my signs are correct. And I see that I have forgotten something, because that y value is negative. This should be a negative value, and so my final answer would be negative 2 square roots of 3 over 3.